Hey everyone, today's problem is longest consecutive sequence. It's one of those problems that's easy to understand but a bit tricky to optimize. So let's break it down properly. You're given an unsorted array of integers. Your task is to return the length of the longest sequence of consecutive numbers, and it must run in O of n time. Now here's an example. From the given input array, the output for this array would be 4 because 1, 2, 3 and 4. These are 4 consecutive numbers, and that's the longest length that you can find in this array. Alright, let's start with the most basic idea that comes to mind. What if we just sort this array? That way all the consecutive numbers will appear side by side and we can count how long the streaks can go. Sounds basic? Let's sort this. This is 1, 2, 3, 4, 100 and 200. This is after sorting. Now you start at 1 and have your length to track the length, that is the longest streak that you are seeing. Go to 2, go to 3 and go to 4 and keep incrementing your length, and at 100 your streak will be broken. And for this sequence you'll see that the maximum length that you've seen is 4. This works, but sorting takes O of n log n time complexity, which is a lot, right? You need to make it better. So let us take a step back and think differently. What's my major goal here? I want to track sequences of numbers. Like for example, in this problem, the sequence is 1, 2, 3 and 4. I need to track the sequences of numbers like this. And the major key is I don't want sorting. So what do I really need? If I'm looking at this number 1, the immediate question would be the next number, which is 2, is this in the array? And after 2, I want to know if 3 is in the array, and so on, 4 is in the array. If I could check this, I could count how long my sequence would go. So one way to quickly do this is using a data structure called hash set. If you use a hash set, what happens is these questions that you ask, like is this particular number in this array, is this particular number in the array, or this particular number in the array, all these questions will be answered in O of 1 time. So that's all it matters. You don't have to keep track of the order of the elements. You just have to ask questions if the next element is present in the set or not. So first step is to throw all these elements into your hash set. So this is my hash set and I've added all these elements here. Now you just have to check if a number exists in the set or not. So let us say we are at 1. Now the next question you will ask is if 2 is in the hash set. 2 is there in the hash set, so we add it. Next one is 3 is in the hash set. 3 is in the hash set. Next one is 4, right? So on. You keep asking this question to build your sequence. But there's one catch here. Let us say from 1 as your starting point, you build this sequence. But when you do it from 2, the next question you'll ask is 3 in the set or is 4 in the set? Now if you observe, this is a subsequence of the earlier sequence that you computed for 1. And similarly for 3, you'll construct 3, 4. Even this is a subsequence of this one. So you're doing a lot of repetitive work. Now you'll have to figure out a way to avoid computing these steps again. You're doing the same work for different numbers as your starting point. So the key point here is you need to figure out if the number that you're currently looking at is truly the start of a sequence. So the only check that you need to do is for every number, you need to check if number minus 1 is present in the set or not. If number minus 1 is present in the set, you don't have to worry about that. It's already taken care of. If you take this example for 3, the number minus 1 is 2. It's already in the set. So this is taken care of by this sequence. And for 2, you'll have to check if 1 is in the set. If 1 is in the set, then this thing is taken care of in this sequence. So you don't have to worry about these two. So for every number, this is the check that you have to do. If number minus 1 is in the set, then you don't have to worry about it and you can safely skip that element. But if it is not in the set, then that's a possible start point of your longest consecutive sequence. So this is the key point here. Now let's do a dry run and you'll understand it even better. First thing is 100. Now the first question you ask is this one. If 99 is present in the set, it is not. So 100 can be a possible sequence. Now let's go to the next number. Once this question is sorted, you'll ask if 101 is present in the set. If this is true, then you ask if 101 is present in the set. It's not. So you just move on to the next number because there's no consecutive number at all to 100. Now the next number is 4. The first question you need to ask is 3 is in the set or not? 3 is in the set. So you can safely skip it because 3 is already in the set and any sequence building is taken care of in this one. Now the next element is 200. You ask if 199 is present. It is not. So this could be a possible start, and when you check for 201, it doesn't exist, so you skip this one. Next comes 1. At 1, you'll see if 0 is present in the set. It is not. So 1 is a possible start of the sequence. Now when you start from 1, you ask if 2 is present in the sequence. It is. So you increment your length to 2. And then you asked if 3 is present in the set. 3 is present. So your length will be 3. And next 4 is also present. So your length will be 4. So after this, you'll check for 5. But 5 is not in the set, so you completely break off from here. So the length from this point, from 1 as your starting point, would be 4. Now you do the same for 3 and 2, but since already 2 and 1 are in the set, you won't proceed. You'll skip just like you skipped 4 here. Now all of this is done in one pass. You just do one pass to build the set and one pass to explore the sequence. So the time complexity would be O of n, and you're using a set, so space would be O of n as well. Alright, let's get on to the coding part now. So first we need to put all the numbers into a set. So let's do that. This is for quick lookup and we created this. Now we need to loop through every number in the set. So let's loop through every number, and for every number the first question you need to ask is the number preceding this number existing in the hash set? So you need to do this check. If it doesn't exist in the hash set, only then we need to start counting from this particular number. That's the beginning of a sequence. So if this is not, then we start counting. We initialize our length variable here, and also we need to initialize our longest. This is to track the longest consecutive sequence so far. So once we initialize our length, now we keep checking for the next number in the sequence. So we can do something like while num plus this length. So if we are at 1, we check for 0. If 0 is not there in num set, then length will be 1. Now after checking that, we need to check for 2. So our number is 1 and length is 1. So 1 plus 1, 2. If this exists in our num set, then we just increment our length. And after 2 it's going to be till 3, after it's going to be for 3, after 3 it's going to be for 4, and so on till that sequence lasts. Now after this is done, we need to update the longest streak if this one is longer. So we need to do longest and the length. That's it. So finally at the end we just need to return the longest streak, and this would take care of the solution. Let's run. Yeah, this works. So this is the problem. Now I'm currently doing blind 75 series, but if you are stuck at any lead code problem, drop it in the comments and I might cover it next. Until then, keep grinding. I'll see you in the next one. Thanks.